All right, hello everybody. It's chapter 1.2. We are applying the order of operations. So here's our learning target over here. By the end of this system of videos, you will be able to apply the order of operations. And you'll notice this says GEMDOS here. If you've done order of operations before, you might have heard of PEMDOS rather than GEMDOS. But I will explain to you the difference and why I think GEMDOS is a better one as we go through our videos here. So let's go ahead and get started. The order of operations. In order to avoid confusion, mathematicians established the order of operations to evaluate an expression with more than one operation. What was happening was that in the 1700s, 1800s, every time a mathematician wrote a book, they would have a couple pages at the beginning of that book that would describe basically like their order of operations, how they were, the conventions they were using when they were solving out all of their work that was in this book. As public education became more popular and as mathematics education began to grow, there needed a need to formalize some of this stuff so that this confusion about how everybody was doing things differently kind of had like one set way. This was especially true with computers because the way that computers read operations, they needed to have a set standard way of doing it for their programming. So the order of operations was kind of created out of a need to organize and keep everybody doing it the same way. Okay, so the way that they did it and decided was that first that they would evaluate the expressions inside grouping symbols first. And when I say grouping symbols, I mean parentheses or brackets or radicals or even fraction bars where you have like something on top and something on bottom. Okay, these kind of grouping symbols. Oh, I forgot one. Absolute values are another one. And like radicals and absolute values will be things that we study this year, but just know that they are considered grouping symbols. What happens inside of them happens first. Okay. Step 2 was to evaluate powers, which we talked about in 1.1. That is these things, right? Anytime we have a power, we evaluate those second. Then we multiply and divide from left to right. They happen multiplication first, then division, and they work in a left to right order. And then finally, we add and subtract from left to right, and again, addition first, then subtraction left to right. Though this one doesn't matter as much as long as you're using the correct symbol. Okay, so grouping symbols, powers, multiplication, division, addition, subtraction, those are our operations that we are using, and this is the order that we do them. So let's do a couple of examples of what we mean here. So here is a nice big problem that has lots of different operations in it. Notice that we have a division symbol here. We've got a multiplication symbol there, a subtraction, and then up here we've got that exponent. So we are going to use GEMDOS, right? And the reason why I use GEMDOS instead of PEMDOS is the P in PEMDAS stands for parentheses, but there's way more than just parentheses, right? We've got all of the different grouping symbols. So that G stands for grouping symbols, meaning parentheses or brackets or radicals or absolute value or any of that stuff, okay? I also like GEMDOS better because it kind of sounds like a monster, right? PEMDOS sounds like something made up, but GEMDOS sounds like a beast, right? Like a giant that's gonna like eat your soul, right? I am GEMDOS. So I think it's easier to remember that way because it's like GEMDOS is scary. Uh, so so let's use GEMDOS here, okay? So grouping symbols, there's none here. Great. So we move on to the exponents. And there is an exponent here, this 3 squared. So we're going to leave the expression the same, except we're going to do that operation, and we're going to get 9 there, times 2 minus 3. So then we have our multiplication and division steps. And again, the multiplication and division, we're going to work left to right. So working this left to right, I say I have 27 divided by 9. and I have 9 times 2. It is important that I work the 27 divided by 9 first, and then what I get left from that, I use and I multiply by 2. So 27 divided by 9 makes 3 times 2 minus 3, which is 6 minus 3. Notice that if I did the 9 times 2 first, I'd have 27 divided by 18, which is 1 point something, right? It's a fraction. Does not give me the same thing. So the order does matter. I do it left to right. Finally, my last step here is the addition and subtraction. And we are also going to work that left to right, but there's just the 1 left. So it's 6 minus 3, which is 3. And we are all done. There's my final evaluated expression. Okay. So I have some of these questions for you to do. They are on your note packet, so please go ahead and run and do those. And we'll go through those step by step in the next video. So we will see you then.